So yesterday we looked at this lab where we did a titration where we found when the hydronium ion concentration equaled the hydroxide ion concentration, because we wanted to know when the hydronium ions ran to completion. Because if you remember, we reacted hydrochloric acid with a strong base of sodium hydroxide. We reacted those guys. But really what we're talking about is what's in solution, the hydronium ion and the hydroxide ion reacting together to form water. And when they react in the perfect ratio with nothing in excess, then we're going to be left with water, which is perfectly neutral. So what we have is this. We had a starting concentration of about 0.01 molar, and we documented this guy as it ran, and as we added more and more sodium hydroxide to this, the hydronium ion concentration went down. The reason for that is because it's generating more water, more hydronium ions are getting used up, forming more and more water. So as we form more and more water, eventually we get to this point right here, and we said that about 7.2 something would be the amount of volume of sodium hydroxide needed to completely and fully react with the hydronium ion to have no excess reagents. So I want to just look at this graph for a minute. So it looks like, and it appears that it runs to 0, right? However, I just want to focus in on this real quick. I'm just going to highlight this portion right here. Okay, and I'm going to go zoom. So right now it looks like it hits 0 about 7.2, basically. We're going to zoom in on that part of the graph. Okay, and so what we can see is, okay, so it is about 7.2 that it actually hits around 0. So we're just going to keep zooming in on this. Keep zooming in, keep zooming in. We're going to see what happens. Oh, so there we go. So this is like 7.2 something. This is like 7.3. Oh, so now it looks like it's reaching 0 about 7.6. So now let's just highlight this portion here and keep zooming in. Okay, so now we're at about this. So it's about, so it's hitting 0 about 7.7 now. Let's keep zooming in. Okay, let's just keep zooming in until we know for sure it's hitting 0. Oh, there it is. Let's keep zooming in. Keep zooming in. Oh, okay. Let's keep zooming in. Okay, well, it looks like it's hitting around now after 7.9. Let's go after 8, and let's just zoom in and see what happens. And there, it looks like it's pretty much at 0. However, let's increase this a little bit for E negative 10. Like that. Oh, my goodness. Wait a minute. It looks like it's not quite reaching 0 until maybe about here. So let's zoom in on this part here. Right here. Oh my goodness. This is the last point that we collected after we had gone way past 7.2. Notice this is at 10 point almost 2. But what we're seeing is that it's still not 0. Still not 0. So what that suggests is that even though, let me zoom back out here, okay? Even though it appears to reach 0 at 7.2, it doesn't actually ever reach 0. In fact, it forms what's called an asymptote, which you guys have heard of before, I'm sure. And, so it forms an asymptote, and when it looks like it's at 0 here, it's not actually at 0. In other words, what we're talking about is when this thing runs to completion. And it looks like 7.2 is the point at which all the hydronium ions are used up. Even after that point, there is still some hydronium ions present in solution. And that's a really important point for us to think about.